Okay, so welcome to the session, Simplifying AI and Machine Learning with Watson Studio. And what I'm going to show in this presentation is how do we bring up machine learning and deep learning workflows from those toy-level use cases and prototype to enterprise-level use cases. Before I go into details, I'd like to shortly introduce myself. My name is Sumit Goyal, and I'm a software engineer at IBM Research and Development Labs in South Germany, and I work on this product called Watson Studio. So of course, I do not even need to start with what machine learning is, deep learning is, and what it can do for your enterprise, but I'll just rightly go ahead to the next level that, okay, a lot of companies are really investing a lot into machine learning and deep learning workflows. But there are all the time reports that those use cases mainly die down at the toy level or prototype level, and they never come to see the value or serve the value with which they were conceptualized. And it's actually not like just a problem, it has several reasons. So here in our presentation, I'm talking about the four main reasons that we identified over time leads to these kinds of disruptions in machine learning flows. So of course, there's no machine learning or deep learning without data. And over the time, we realized that there are big enterprises and the data lives in silos. So if you were in keynote today morning, there was very interesting problems that could arise if your data lives in silos. So, and it's a real problem with enterprises which have been serving data for 50 years. Data is at so many abstract, small places in silos. There's no connection between data. When those databases were designed or data lakes were designed, there was actually no concept of unstructured data. So they were not even thought of that we'll have to someday merge our data with weather data or with images or audios or Twitter data, things like that. There's another sector to that or pillar to that problem is the governance. So there are huge companies, banks, insurance companies, and they just do not want to hand over their data to anyone, right? So they really have to know that the data which just goes out is in secure hands. And also the person who's using the data really want to be sure that I'm just not using some data, I'm using it from a truthful resource. And also about the data lineage, right? So imagine I'm a company and I'm working with a team of data scientists. I really have to know in all the time who is dealing with data and who is doing what with this data, not just with intellectual property rights point of view, but also privacy policies. And data skills, I'll go to the third pillar, skills. Data skills are in high demand and low supply, so there's actually not that easy to nurture those skills over time. And tools and infrastructure. This is actually one of the prime reasons why a lot of data science projects fail, because apart from my data development work, I also go to some client engagements for IBM, and we have seen cases where there's a team of 6 data scientists, and all of them are using different tools. So one of them is using Python, one is using SAS, one is using SPSS, one using MATLAB. And after investing 1 month or 2 months of time doing stuff, after that there's actually really no way they can collaborate what they learned over time and then build quantitative collective value on that. So what I'm presenting is Watson Studio, and with Watson Studio, we are trying to solve a lot of problems that I just mentioned here. So if you were in keynote today morning with Rob Thomas, so there was a demo where he showed this collaborative platform that was meant for enterprises which have on-prem installation of that. If you go to the cloud world, that's called Watson Studio there. And there's a lot of hype around machine learning, deep learning. But if you look deep down, it's not really magic. So you can actually compare it with a different complexity of software development projects. So it's actually algorithms, which when you apply on data, which could be structured, unstructured, and you have to have a team with different kind of skills, and then it leads to a success of a artificial intelligence project. We divided that into, for when we were developing Watson Studio, we said, okay, we want to develop it for a collective team effort. For example, here it says built for AI team. So we say if there's any machine learning project which is of considerable complexity, so it cannot be just done by one person, right? So there has to be a team where there's a person who has a domain knowledge who's okay, this makes sense, this does not make sense, the sales numbers, marketing numbers, things like that. And then there's like 2 or 3 data scientists who really do the core, like dirty hands data munging kind of thing. There's data engineer whose job is to like run ETL pipelines, bring data from different sources together and scale them. And then there's a developer who's like, okay, I have my model running now. How do I make it available to different people? How do I make it, how do I monitor, how do I make it available to the microservices, for example? So with Watson Studio, we said, okay, we want to bring all of those parties which collaborate or contribute to a machine learning project at one place. And we promise to support the machine learning workflow from end to end. So we don't say, okay, we just do this part of your machine learning, and now you have to design this part of the flow and the rest of it yourself. So because then we are not actually solving the problem. So the way it starts with Watson Studio is that you have your data could be relying anywhere. It could be IBM Cloud, it could be a third-party cloud, it could be on-prem. So you have data connectors to bring data from different sources to one toolkit, so to say. And when your data is in the toolkit, it resides in a knowledge catalog. And it just does not have to be data. It could be your data assets, it could be your Jupyter notebooks, it could be your models, and then you augment that data with writing tags. What's the proficiency level of this data? How useful is data? Things like that. And then you go with prepare an analysis step, which is, like you say, data, it's a very known fact that you spend really a considerable amount of time cleaning the data. For that, you can design pipelines, right? So if you know if there's a sensor data which is producing data in strings that you have to convert in integers, for that you can design pipelines so that over the time do it automatically for you. Then there's a build and train ML and DL models part. The part about that is we are supporting different kinds of complexity of tools there. So there are not a lot of people who really want to code machine learning and deep learning models. They are very happy with the SPSS modeler kind of flow where you have like click-through model like flow where you click things together, and then at the end you have a machine learning model. And the deploy models parts, which is actually a very important part of the whole flow, and not a lot of people talk about it. So the real value of a model just comes up when you actually deploy it and make it available to the enterprise. Because otherwise, it's just investment, building that model, hiring data scientists, hiring data engineers, but you really serve value to the enterprise only when your model is deployed and it can be consumed by other applications. And not just that, after that, if you deploy that model to a production, you really have to have a robustness level or a level of confidence and security that your model is serving what it's meant to be. And if it goes, the performance goes below one number, you have to have automatic retrain with Challenger kind of model. So in the platform, we are supporting various kinds of open source tools and IBM proprietary tools. So let's start from the top, which is like authoring tools. Authoring tools is like where you start writing your machine learning flows. You can do that with Jupyter notebooks in Python 2, Python 3, or Scala language of your choice. And for the people who are really in love with R, they can just do that with R Studio. That's the de facto tool for people who are working with R. And then there are IBM tools, for example, SPSS Modeler, which used to be an on-prem product, is now on SPSS Modeler on cloud, if you know about that. And then there are data refinery products. Actually, just to know that, so don't get bored with the PPT. Half of it is a demo where I'll be just showcasing or demoing everything that I say here. Now we come to the second layer, which is like, okay, if you're doing your machine learning runtime, so everybody knows about Spark. You have very tightly coupled Spark engines running in there, so you can run notebooks with Spark, you can run RStudio with Spark. If you're happy, if your complexity of model is not that big or it's not distributed, you can do it with a sklearn model, XGBoost, and then if you go to the area of deep learning, you have then Torch, TensorFlow, Caffe, everything built in there. And when it comes to the deployment layer, you have all those fancy concepts where you can deploy it as Docker containers in Kubernetes infrastructure, or if it's a model which is using GPUs, then you have a variety of NVIDIA GPUs available for you. Exactly. So as I think I already said before, we really believe that data science is a team sport. So the way we envision it works is like a person who conceptualized a project or who came up with a data science or machine learning problem, creates a project, and he invites different people to a project, for example, the domain expert, a data scientist, a data engineer, to really work on this in this project. And then he has this option of bringing in data from various sources to the project. So it could be IBM Cloud, it could be other clouds, for example, it could be Amazon S3, and it could be an on-prem database. So you bring in your data in there, and the project then gives you this envelope of like consolidating assets from different sources where you work upon your project. And after that, if you realize in the cycle of your project that, okay, I did something which is even useful in other projects, you can push it to a catalog, and it can then be used by other people as well. This is a pretty filled-in slide. I won't go into details because I'm showing most of that in the demo that I go through. Yeah, this is actually an important slide because the message here is that we do not want to lock you in some kind of one cloud or IBM cloud. So you have, like IBM offers you with most kind of data sources like NoSQL, DB, relational databases, graph databases, streaming analytics, but it just not has to be that, right? It could be a on-prem database. For that, you have the third-party connectors. It could be like Microsoft Azure SQL database. It could be Amazon S3, Hortonworks, HDFS, Oracle, Sybase, things like that. And if it's on also IBM on-prem systems, there's a tight coupling with that. Jupyter Notebooks. So a quick survey here. How many of you already know about Jupyter Notebooks? Okay, good. Half of you already. Good, enough. So I would say that the way I think about Jupyter Notebooks is it's like a smarter version of normal scripts. So they are interactive documents where you can write your code as you write in scripts. You can run it in real time. And the good thing about that is that it also documents the outputs of that. That I'll also show in the demo, but a good thing is about you can write markdown code in there, so which explains what you are doing, kind of the replacement of comments that you write in your script. But the advantage that it also puts in the value that you brought up. If it produces a plot at the end, you can put plot in the script like that. Exactly, so it's one of the very, very famous open source projects. I think it has a lot of contributors. It's growing very fast pace. You can run them with Python, R, Scala, and actually virtually any language of your choice. You can actually do it with Go if you like. And it's not just useful in data science project, but actually any project at the end which you need to generate a report, basically. Exactly, so this is the part which we call as Watson machine learning. I would really like to go into details of that because when it comes to authoring the machine learning models, it's pretty known. It's like it's a known world. Okay, you have these tools, and then you do a model. But what do I do with this model, right? So, for example, in Watson Studio, you could be writing notebooks or flows or wizard, the click-through thing that I told you about. You create a model, but then you also have opportunity to deploy that model directly with one click to a deployment. So what happens in there is that you say, okay, this is my model, this is my evaluation score, I like it, let's deploy it. What happens then? It deploys it, takes your model, serializes it, puts into a Docker container, deploys somewhere, and then gives you a REST endpoint. So you basically, in 2, 3, 4 minutes, have application, and then you can start calling the application. Yep, so since I think most of you already know about Watson, so Watson is the, let's say, the AI face for IBM. And we have a very tight coupling with all the most of the Watson APIs, or it's coming. So for example, Watson has a very strong model, which is IBM proprietary, which works in the field of image recognition. So what happens in there is that you upload zips with training images, which has labels. You say train a visual recognition model. It basically kind of clicks, and then at the end you have a model which is trained for your images. Visual dashboard. So this is, if you remember in the beginning, I showed a persona which was called domain experts, right? So this person might not really be into coding, or really does not have to code. For that, you have dashboards. For example, kind of those Tableau dashboards you have. You can bring in data from different sources. It could be live data if it's a database connection. Your database is updating in real time, and your dashboards are also updated. You can share those dashboards with different people. Watson Knowledge Catalog. This is the part which does the governance part that I told in the beginning, right? So you bring in data from various sources, you put in the knowledge catalog. Now in the knowledge catalog, you have the option of defining governing policies on data set. You can say, okay, this is my data set, this is a secret data set, only these class of people can access it. And not just that, over the time you also have the lineage over the data. Yeah, those are the possibilities, how it differentiates and tries to solve the problems. I'd actually really like to switch to the demo mode now. Perfect. Okay, so pardon me if I write stupid stuff in there because it's not my system and it's not the same keyboard that I'm used to. Exactly, so this is Watson Studio landing page. And as you see here, it's basically a cloud-based service, so you're not downloading or installing anything on your system. You just need an email ID, and then you're good to go. What happens in there, this is the landing page. It says, OK, welcome, Sumit. How are you doing? Things like that. And it also tells you the recent projects that I worked upon. For example, I recently created a project called Credit Card Fraud Detection. Let me go into that project here. Now it says you have 11 assets in that project. What does that mean? That I have 11 useful things that I'm working on this project. There are 2 collaborators in this project. Let me go to this Collaborators tab, for example, here, right? I say, OK, 2 people are not enough. I need a help of my colleague whom I want to work on this machine learning problem. I say, OK. OK, I want to oh, he's already in there. Let's say this is another colleague of mine. I say, OK, what kind of access level do I want to give him to this project? If I do not trust him so much, I would say he's just a viewer where he can see things that I'm doing. With editor, he can do things like edit things, change things like notebooks. And in admin, he just says, he basically has full control over the project. I also briefly go through the settings page where you can decide, OK, yeah, one thing that's important to mention is that whenever you create a project, there's always a cloud object storage bucket associated with your project, which is kind of a backyard for your data science work, right? So you can connect with different databases and CSV files and things like that. But you also need something in real time where you can just throw dirty in data, right? Just try out things. OK, with that, I will go. I'll just follow a pattern here. So here I have a CSV file called creditcard.csv. This is a real data from a credit card company. Let me just open that data for you. OK, I say I already have. Oh, OK, good. Let me tell you how does data come in here, right? So you say, OK, there's data already in my project, but how did it come? So I go to the 0101, which says this is my data. I can look for my data sets. For example, oh, OK, this is not my system, so I don't have CSV files, but I'll just upload this file here. In the real time, this file is uploaded to my project, and then I have a file in my project. So similarly, in my project earlier, I created a CSV file. I go to the CSV file and say, OK, I want to refine this file. And the idea about the refine is that your data is more or less never in the form that you want to work it in a machine learning project. So you have this capability of defining or creating data refinery pipeline. So you can connect it to a database, and you define some rules. So whenever new data comes in, do this to my data, do this, do this, do this, and then it's useful for my use case. Just see if I have. OK. Yeah, so my data is loaded now. To give you just brief overview about what the data is. So this is about credit card transactions. It has 31 columns about different factors of credit card transaction, but it's anonymized data. So the company changed the data to a form that nobody can understand it. At the end, what the important thing is that it has. OK. Yeah, so this has what was the amount of this credit card transaction, and class is 0 or 1. 0 is a non-fraud transaction. 1, it's a fraudulent transaction. So here you see my class is for some reason a string, that does not make sense. So I would say, okay, I want to convert the column type, and it already gives you a suggestion. Oh, it looks like you already have string, but it should be an integer, by the way. So you say, okay, change it to an integer. What it will do is it will create a step in your pipeline for that. Same, let's do it with time. You say convert column, you want it to be an integer. And then you can save this pipeline. So this is a CSV file. It will just run a job and finish it. But if it's a database, you can specify do it every hour. So as your database is being populated, it will run these jobs. And here is, as you see, you have this option. By the way, can you read on my screen, or is it too small? Great. You can add schedules on that, right? So if it's a one-time thing, or I want to repeat it every day, hourly, I want to repeat it an hour, and end it on this date. So it basically gives you a control and doing the job of an ETL. Let me go back to my credit card transactions database. I talked about notebooks briefly. Let me open a notebook. So this is how Jupyter Notebook looks like if it opens. Yeah, exactly. So you have this possibility of running your notebooks with different variety of environments or, wow, like resources that you want to run your notebook with. So this is my notebook. I will turn off this hopscotch tour. I can load data to my notebook. For example, let's see, right? This is my data set here. Credit card CSV. Now a database or data scientist don't have to go around and look, okay, how do I load the data to a Python notebook? Here's like already created code for you, which just generates code that you need to read the data from a cloud object storage into a Jupyter notebook. It will run this and show you the output for this data. You can go ahead and write code, install libraries you like. So it's kind of an IDE for data scientists. Just to give you an idea of this is the transaction, like most of the transactions are non-fraudulent, but there's a small percentage of transactions which is fraudulent here. So this was the notebooks there. I also go ahead and quickly show you about the VR capabilities that I briefly talked about. So I'm connected to the conference Wi-Fi here. Oh, wow. Just give me a second if this loads here. Yeah, so this is, I actually wanted to show you how easy is it to create a VR model with this. I hope this page loads. So basically, this is a model that I created for identifying if images is kind of a USB connector or a VGA mail or Thunderbolt or HDMI. So here you get a test for this, for which I can just load a, let's say, image. I'll just copy this image here, save image as index. I save it at desktop, save. Then I go to my model, which was here. I say I want to browse. It was index.js. And then it's loading the results based on my model. It says it's 89% sure that it's a USB mail. Maybe that's not interesting here, but what's the interesting part is here. Right, so it's building upon the AI developer story. So you build a model. Now you want to operationalize this. How you do that? So you build the model. After that, you have the code generated for you in most like widely used languages, where you can just actually copy this code, put it into your AI application, and it's good to go. Not just that, if one of you is a Swift developer, there's actually code generated for Core ML. So you just take this code, right, to get a Swift SDK, Xcode SDK, and you're good to go. Okay, exactly. So we are model. Just give me a second. So I also talked about dashboards, right? So dashboard, it's, you just say, okay, my dashboard. And then you have this free flow of, if any of you are used to Tableau, that you have a form, and then you have ways of loading data to your form, and then like doing different kind of analysis there. You have free forms, some defined forms. You say, okay, I want to start with empty form. The flow that I showed with notebooks was actually pretty kind of to the details, are very developer-centric. So, but there's also kind of assisted flow. If your data science model or machine learning problem is not that complicated, you can start with flow builder, which says, okay, I want to do it step by step with assisted flow. It says, okay, let's start. On which data set you want to work? You say, I want to work with a credit card data set. It will initialize the kernel, load your data to the kernel. We'll ask you which is your target column, which is your feature columns, and what kind of classifier do you want to build on this one. Just give me a second when it loads the data. Exactly, right? So it says here, my target column is the class. I want to identify if it's a fraud detection or not. Take my all feature columns. Then it identifies, okay, it looks like it's a binary classification problem, fraud, not fraud. And then you can say my validation and train split is this. I want to do an estimator, which is like, let's say, decision tree classifier. Add this, and then train my model. What it will do is it will take all your data, train the model, and then give you at the end, say, okay, this is a performance score. Do you want to deploy this? You said, okay, I want to deploy this. It gives you an endpoint like this one here. So this is a fraud detection demo. It was done with scikit-learn. You can test it. Then it gives you an UI where you can just post a JSON file, and then your model is good to go. Exactly, that was from my side. I think we have 3 minutes for questions. And if anything of it captured your interest, I'm here. Just catch me anytime. I would really like to talk about it. No questions? Good. Thank you, everyone, for coming to the